Good. We are going to need our math booklets for this one. So get out your math booklet. Make sure your name is at the front. And then you can page with me. 1, 2, 3, 4. Good. Let's take a look at the first number lines worksheet. It says write the missing fractions in each number line. Now, this is very straightforward. And I'm going to explain it to you still, but just look at what I'm saying. 0, 1/9, 2/9, 3/9, 5/9, 7/9, 1. What are the missing numbers? Let's see. 0, 1/9, 2/9, 3/9, 4/9, just like normal counting, 5/9, 6/9, 7/9, 8/9. There are no tricks on this page. The only thing that I really want you to remember, the 1 here at the end could also be said to be 9/9, because remember, as soon as the number at the top and the bottom are the same, it means it's a whole. Because, now I have to divide this into 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Oopsie, wait. Oopsie. My word. Sorry. Okay. That's divided into 9. 9 out of the 9. So I'm coloring 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that I've colored 9 of the 9, do you see that it's a whole? It's a whole shape. So a whole is 1. That's why 9/9, 8/8, 5/5, 2/2, whatever, all of those are known as 1. Okay, so keep that in mind. And then it is just normal counting. Let's look at number 4, for example. Actually, let's look at number 2. 0, 2/5, 3/5, 4/5. So 0, 2/5. That means this will be the number that comes before 2, 1/5, 2/5, 3/5, 4/5, and then you can either write 5/5 or you can write 1 because it's a whole. Actually, I would like for you to write 1 so that I can see that you know that when the numerator and the denominator are the same, it counts as a whole. So this worksheet is very straightforward, but I would like to move on to the second one. You can go do that one in your own time. You can do that now. Before we start with this one, you can go back to the other worksheet, quickly complete it, and then I will explain this one. Good, so there's space for the date at the top of this one. It's the 2nd of the 10th. All right, now this says equivalent fractions on a number line, okay? I want to show you, Ms. Kanondo and I want to show you, kiddies, what we mean when we say a fraction is equivalent. Now, with fractions, every single fraction in the world exists on a number line because it is a number. Now, every single proper fraction, do you remember we said proper fractions are fractions where the numerator is smaller than the denominator. Not a mixed fraction, not an improper fraction. We're simply talking about proper fractions now. Every single proper fraction exists between 0 and 1. Okay? Every single proper fraction exists between 0 and 1. Now, that means all of the 9ths exist between 0 and 1. All of the 8ths exist between 0 and 1. All of the 12ths exist between 0 and 1. All of the 26ths exist between 0 and 1. Okay, so there are a lot of fractions that fall on the number line, actually limitless fractions that fall on the line between 0 and 1. Now, one thing that you will have to keep in mind is when this happens, sometimes some of the numbers overlap. Okay, if I make a number line showing halves and I make another number line showing quarters, there is a possibility that some of those numbers are going to fall on the same spot. And that is because you have to remember a fraction is actually a picture, right? Like we've shown you. It's either the pizza, the circle, or the chocolate, the rectangle. So some of them look exactly the same. And those that look exactly the same are the ones that exist on the same spot on the number line. So let me show you what it is that I mean. They say label the two number lines below with fractions. Now I'm going to do this entire 1, 2, and 3 with you. Number 4, 5, and 6, I want you to go and do by yourself. So you need to please focus nicely on what I'm going to say in this area. Okay, it says, label the two number lines below with fractions. Now, we need to go figure out what fractions should we fill these in with. Remember, a whole, or the 1, is the same as any number that's the same at the top and the bottom, at the numerator and the denominator. So, let's go through our fractions and see which ones fit. Let's say a half. Okay, we start with a half. 2 over 2. No, 2 over 2 would have to exist here because when any number is the same at the top and the bottom, it is a whole. So this is not a number line for a half. Let's see. 1/3, 2/3, 3/3. Does that one fit? Yes, because 3/3 is the same as a whole, and that is where the 3/3 landed. So this will be 1/3, 2/3. So you're basically trying to count in such a way that when the numerator and the denominator are the same, they fall on the 1. So let's see on the second number line what we can figure out. Let's try halves. Half 2 over 2. Nope, because the 2 over 2 would have to fall on the 1. 1/3, 2/3, 3/3. Nope, the 3/3 would have to fall on the 1. Okay? A quarter, 2 quarters, 3 quarters, 4 quarters. Nope. We want the fraction where the numerator and the denominator is the same to fall on the 1, because then it becomes a whole. So no, we are not going to count in quarters. 1/5, 2/5, 3/5, 4/5, 5/5. Nope, because the 5/5 would have to fall on the 1. Let's try sixths. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Yes, because we want the numerator and the denominator to be the same. So this one works out perfectly. So we write 1/6, 2/6, 3/6, 4/6. It's very difficult to say. 5/6. Good. So there are the steps that you will take to fill in your number line. Now, let's look at what they are asking from us. They're saying, use the number lines above to identify two sets of equivalent fractions. Equivalent fractions would be the fractions that exist on the same spot of the number line because they look the same. Now let's take a look at it, shall we? 1/6 looks this way. Let me just quickly make all of these sixths. Why is that so difficult to say, my word? I just want to show you picture-wise so that you get the idea of what is actually going on here. Remember, each fraction can be drawn as a picture to understand. Now, the size of the fraction needs to get bigger the further you get away from 0. So let's see. 1/6, we color in 1. 2/6, we color in 2. 3/6, we color in 3. 4/6, we color in 4. 5/6 we colour in 5. And 6/6 we colour in all 6. So do you see that the black, the shaded part is getting bigger and bigger the further away we're getting from 0? Like normal counting, the number gets bigger away from 0. Now, let's look at our thirds at the top. I'm just going to draw them to the side a bit. I just want to see, how did I do these ones? Like that. Like that. Now they want 1/3, so we shade 1/3 of the picture. 2/3. You don't have to draw the pictures, grade you two at home. I just want to show you. I want you to see it. Now they are asking for us to write the two equivalent fractions. Now I already told you that it's the two numbers that exist on the same spot on the number line. So it would be these two. But take a look at the pictures. 1/3 and 2/6. Do you see, I know that I drew this one smaller, but do you see that they are the same shaded area? And that also helps to tell us that they are equivalent fractions. That's why they exist on the same spot on the number line, because they cover the same size that is going to lead us to the whole. Okay, so 1/3 and 2/6 exist on the same spot on the number line, so they are my equivalent fractions. And also 2/3 and 4/6. They also exist on the same line on the number line because they cover the same shaded fraction that is going to lead us to the whole. So 2/3 and 4/6 are also equivalent fractions. If you want to test this even more, you can do the multiplication test. What happens at the top must happen at the bottom for it to be equivalent. Let's see. 1 times 2 gives me 2. 3 times 2 gives me 6. The fact that we times with 2 at the top and the bottom confirms that they are equivalent. You don't have to write all of these extras. I just want you to fill in the spaces. I'm just showing you. The same this side. 2 times 2 gives me 4. 3 times 2 gives me 6. Those two are exactly the same, so that confirms that this is an equivalent fraction. All right. You can go and try and do these ones. Start with a half. Remember, when you get to the 1, you want the number that, or you want the fraction that is the same at the numerator and the denominator. So keep that in mind when you try 4, 5, and 6. But you will be able to do it.